Dear students, this session we are going to study about standard distributions. There are two types of standard distributions. One is discrete distribution, another one is continuous distribution. Under discrete distribution, we have binomial distribution, Poisson distribution, and geometric distribution. Under continuous distribution, we have uniform distribution, exponential distribution, gamma distribution, normal distribution. Okay. So this session we are going to study about discrete distribution. Okay, so first discrete distribution is binomial distribution. So first here we are going to see binomial distribution. The probability of x-axis in n trial is given by p of x equal to x ncx p power x q power n minus x, where x running from 0 1 2 3 up to n. Okay, this distribution is called binomial distribution, where p refers probability of success and q refers probability of failure. So relation between P and Q is P plus Q equal to 1. Therefore, Q can be easily determined from this relation, Q equal to 1 minus P. Assumptions in binomial distribution. There are only two possible outcomes for each trial, either success or failure. The probability of success is the same for each trial. There are n trials, all the n trials are independent. Okay. So next distribution is Poisson distribution. Poisson distribution is a limiting case of binomial distribution under the following assumption. The number of trials is independently large. That means n is large. Okay. The probability of success for each trial is independently small. Probability is very small here. Lambda equal to np, that is lambda is constant, that is mean here. Okay. The probability mass function is defined as like this: p of x equal to x e power minus lambda lambda power x by x factorial, where x running from 0 1 2 3, lambda equal to np here, n into p. Next definition is geometric distribution. A discrete random variable x is said to follow geometric distribution if it achieves only non-negative values and is given by p of x equal to x p into q power x minus 1, where x running from 0 1 2 3 and so on, or p of x equal to x p q power x x running from 1 to 3. Can you say either this definition or this definition? Okay, right. Now find the mean mg of mean and variance for binomial distribution. Right, moment generating function is defined like this: expression of e power tx. Okay, so this is discrete case, so use summation form. Okay, summation x running from 0 to n e power tx into probability function p of x equal to x running from 0 to n e power tx. Probability function is binomial distribution is ncx p power x q power n minus 6. Okay, right in same power e power tx p power x, common is power x here. Okay, I arrange like this. Now expand the summation, put x equal to 0 here, nc 0 e power t power 0 q power n minus 0 is n. Similarly, put n equal to 1, nc 1 e power t p power 1 q power n minus 1 and so on. Right, now apply binomial formula becomes after simplification we get e power t p plus q power n. Okay, to find mean and variance, differentiate this moment generating function with respect to t. First differentiate this gives n e power tp plus q power n minus 1 e power tp. In differential linear function we get e power tp. Okay, put t equal to 0 here. Formula for first moment, that is mean, that is e of x is m dash of x equal to 0. Put t equal to 0 here. E power 0 become 1, therefore np p plus q power n minus 1. P plus q is 1 here, therefore mean is np. Again differentiate this with respect to t. Right, using UV formula we get a large expression here. Put t equal to 0 here and apply t equal to 0. We get this expression. Put p plus q equal to 1, again we get this equation. Okay, so apply variance of x formula. Variance of x formula is e of x square minus e of x the whole square. So what is e of x square? E of x square equal to np n into n minus 1 p square minus e of x is np the whole square. After simplification we get np into 1 minus p. 1 minus p is simply q. Therefore, variance of x is npq. Okay. Now, find a moment generating function mean variance for Poisson distribution. So, moment generating function formula is expression of e power tx. So, this is also discrete case. So, use summation form x running from 0 to infinity. E power tx p of x equal to x. Okay. Apply distribution function for Poisson distribution here. E power minus lambda x by x factorial. Now, grouping x terms here, we get like this. Okay. Now, apply summation x running from 0 to infinity. So we get a lengthy series. So nothing but exponential series. Applying exponential formula, we get e power minus lambda plus e power t lambda. That is e power lambda e power t minus 1. This is moment generating function. To find mean and variance, we have to find e of x and e of x square. For this, differentiate this with respect to t and apply t equal to 0. Right, if you put t equal to 0, if we differentiate this, we get like this expression. Put t equal to 0, we get lambda. E power 0 is 1, so we get lambda. So mean equal to lambda here. Again, differentiate this with respect to t. Apply UV formula. Put t equal to 0, we get lambda into lambda plus 1. That is e of x square is lambda square plus lambda. Formula for variance of x is e of x square minus e of x the whole square. Okay. Applying all the values here, cancelling plus lambda square minus lambda square, we get simply lambda. Next, find the mean, variance and moment generating function for geometric distribution. So again, moment generating function formula for is e power, if expression of e power tx, apply summation x running from 1 to infinity, e power tx p of x equal to x. Okay. Again, grouping x terms, we get this expression. Taking constant terms p and q away, we get p by q, x equal to 1 to infinity e power tq into x. Now, applying expand the summation, we get a lengthy expansion. Taking common factor e power tq away, we get this simple term. Okay. To get to find the mean variance, we need e of x and then e of x square. To find e of x, differentiate this with respect to t and apply UV formula. After simplification, put t equal to 0, we get p by 1 minus q the whole square, that is p by p square 1 by p. Similarly, differentiate again with respect to t, we get differentiate this expression, right? And apply u by v formula, we get a lengthy expression. Okay. And put t equal to 0, we get e of x square equal to 1 plus q by p square. So variance of x formula here is e of x square minus e of x the whole square. After simplification, we get q by p square. Okay. Now, state and true memoryless property of geometric distribution. So, memoryless property. Probability of x greater than s plus t over x greater than s is simply probability of x greater than t. So, here the variable s is forget here. Therefore, that is memoryless property. Right. Now, the probability function for geometric distribution is p of x equal to p into q power x minus 1. P of x greater than, we have to find these three terms. P of x greater than s. Okay. P of x greater than s is p of s plus 1, s plus 2, s plus 3 and so on. Put x equal to s plus 1 in the formula, we get pq power s. Similarly, s plus 2 in the formula, we get pq s plus 1 and so on. Taking common term away and applying binomial series formula, we get pq power s 1 by 1 minus q. 1 minus q is p. Cancelling common term, we get q power s. Therefore, p of x greater than s is q power s. P of x, therefore, p of x greater than t is power t. Simply replace s by t. Similarly, p of x greater than x plus t can be written as q power s plus t. Okay. So this is nothing but conditional probability. Okay. Applying formula for conditional probability, p of x greater than s plus t by p of x greater than s. After substitution and after simplification, we get q power t. Q power t is simply p of x greater than t. So, prove. Right? Find the binomial distribution for which mean is 4 and variance is 3. Also find p of x greater than or equal to, find the probability mass function. So here mean equal to 4, that is n into p is 4. Variance equal to 3, n into p into k is 3. Okay. Now dividing this expression, we get q equal to 3 by 4. So we can easily find the p equal to 1 by 4. Using main formula np equal to 4, we can easily find n equal to 16. Substitute all the values in the binomial distribution formula. We get 16 cx 1 by 4 over x 3 by 4 16 minus 6. X running from 0 1 to 3 up to 16. So first question here is p of x greater than or equal to 2. Okay. P of x greater than or equal to 2 means we have to simplify 2, 3, 4, 5 up to 16. Instead of using that expression, we can simply apply its complement rule. 1 minus p of x less than 2. What is p of x less than 2? P of x equal to 0 plus p of x equal to 1. Put x equal to 0 here and 1 here. After simplification, we get this value. Okay. To find a probability mass function, substitute x equal to 1, 2, 3 and so on up to 16 in the distribution formula. Right. After simplification, we get the probability mass function formula like this. Okay.